Let's practice evaluating and solving giving a graph. So I'm going to, just so it makes it easier for you to see, I'm going to make this f function pink so it's kind of highlighted so you can see the difference whenever we're working here. All right, what I want to do on the first one is I want to find f of 1 and add g of 1. So I'm going to find f of 1, so I'm going to go to 1 as the input and find the f function, and it happens to be at 1. And I'm going to add the g function at 1. So I'm going to go to 1 and go up and find the g function, and it is at 4. So f of 1 plus g of 1 is 5. Okay, let's find g of 0 minus f of 0. So the input is 0, and the g function is at 4. The f function at 0 is down here at negative 2. And 4 minus 2 is 2. Okay, let's multiply f of 6 times g of 6. So I'm going to find what f of 6 is and what g of 6 is, and I'm going to multiply those two together. So the input value this time is 6. The f function is at 1, 2, 3. And the g function at 6 is down here at negative 1. And 3 times negative 1 is negative 3. Okay, let's find f times g of 8. So this time the input value is 8. I'm going to go to 8 for the input. The f function is down here at negative 3. And the g function at 8 is at 1. Negative 3 times 1 is negative 3. Okay, let's go find f divided by g at 4. So I'm going to find f at 4 and divide it by g at 4. So I want to find input value of 4. At 4, the f function is at 1, 2, 3. And the g function at 4 is 1. So the answer would be 3 because 3 divided by 1 is 3. Let's find g of 1 divided by f of 1. So the input value is 1, the g function is 4, and the f function is 1. Okay, last one, f divided by g of 5. So input value is 5. The f function is all the way up here at 5. And the g function of 5 is 0. This is a problem. The new function that we've created is actually going to be undefined at this place because you cannot have 0 in the denominator. So let's talk a little bit more about domain restrictions. They're going to apply sometimes whenever you have division. Let's look at this first problem here. If I wanted to find f of x divided by g of x, my f of x is 2x plus 1, and my g of x is x plus 3. Now, we know that this one is linear, and we know that this one is linear, because when I graph 2x plus 1, it looks like that. When I graph x plus 3, it looks like this. So we know to start off with that our domain is negative infinity to infinity, because that's the places where they intersect. But there could be a place, just like this last example, where when I divide, I actually get a 0 in the denominator. And if that's the case, there isn't going to be a graph for my new function at that place. There'll be just like an open circle because we can't have 0 on the bottom. So let's think about what that would look like. What kind of number could I put in for x that would make this have a 0 for the bottom? If I put 0 for x, I would get 3. If I put 3 for x, I would get 6 on the bottom. What number could I put for x that would make it 0 on the bottom? Yeah, the number we wouldn't want to have is x could not be negative 3. Because if I put negative 3 in for x, that would make a 0 in the denominator. So I would say my domain is every number except for negative 3. Let's look at the next one. I've got f of x divided by g of x. F of x is x squared plus 1. G of x is x minus 4. Now, this is a quadratic and this is a linear, so our domain is negative infinity to infinity. But I am going to have a restriction. The restriction that I have is the number that would make this bottom part equal 0. So I don't want x to be 4 because 4 minus 4 make a 0 on the bottom. Okay, let's look at the last one. This time I'm doing g of x divided by f of x. So g of x is x minus 4, and f of x is x squared minus 9. So I've got linear and quadratic, so the domain is negative infinity to infinity, but I am going to have a restriction. I don't want this bottom part to be 0, so I have to think what number could I square and subtract 9 and get 0. Sometimes that's hard to see. Well, some of you can already know, well, x can't be 3, right? But x also can't be negative 3 because negative 3 squared is also 9, and 9 minus 9 is 0.